Hello, hello. Hi, everybody. And welcome to our fourth little session here of our free Introduction to RStudio series. Today, I want to just chat with you guys about data visualizations in R. How can we make cool looking plots, figures, graphs? And we're going to be doing that using the ggplot package. So that's what we're covering today. And we're going to be using histograms as our first example of a plot type. So histograms are going to be your example when we're talking about using ggplot. All right, let's go forth. Today, we're going to be working with a brand new data set. As always, you can access the data set that we're using for whichever video that you're on by looking in the video description, clicking on the Google Drive link, and there you can download the data set, the PowerPoint, all of the materials for that week. So make sure that you do have the spiderdata.csv data set in your computer, and that you're going to be accessing that with your working directory, like we talked about in week 2, which was Introduction to Working with Data. So if you're a little stuck on how to get your spider data into R, you can just quickly review the beginning of that video, check it out, and it should help you. So I have my working directory set already. I have the data downloaded already. So all I have to do is call it my data equals, and then read.csv in my spiderdata.csv. And this data set, it's pretty neat. It contains around 700 rows of data on individual spiders, including a unique identifier code for each one, the location that the spider was found, the type of web that the spider has, the length and width of the spider web in centimeters, the size of the spider in millimeters, and the taxonomic family and genus of the spider. And there's something a little unique about this data set that last week's did not have. As you see, we have some unknown values in the data set, and this is new. Spider size also has some missing values, and there are some blank cells in the data too. And all of this is very problematic. R doesn't deal with these types of values well. Typically, what R will do is it'll read in values like this as a string. It's just text. Unknown is text. So what it will do is it'll make the whole web length column a character class. And that's no good. What if I want to plot web length versus web width on a nice scatter plot? Well, that's not going to work at all because R says that 14 is text and 12 is text because it assigned the whole column to being a character due to this unknown. So we really do not want this. We don't want this at all. So we can avoid this problem by assigning NAs. NA means non-applicable, and these values are ignored by R when assigning variable class. The example below shows how we can modify our read.csv function to assign certain values as NA. Here we have my data equals read.csv spiderdata.csv, the same as before. But now we're adding in this extra little section here, na.strings equals. And then here we put a vector of all of the values we want to make na. So I want anything called unknown. Unknown should become an na. And also, what's going on here? This is blank. So there's nothing. If there's nothing in the cell, I want it to be an na. Because otherwise, R will read it as a string that has nothing in it. And I do not want that. So what R will do is it'll take anything called unknown and any blank cells and assign it NA. And that's good. So please make sure you're doing that. Otherwise, we're going to have some issues moving forwards. So now what do we do once we have the NAs? Well, there are a couple different things we can do. We can choose to just omit entirely all the rows with NAs from our data frame. So just if a row has an NA, take it out. I don't want that. I don't want that in my life. Alternatively, we can choose to exclude NAs only when they would be included in an analysis or a figure. There are other things we can do too, but I just want to talk about this for now. And since this is our first time working with NAs, we're going to work on this first solution here, just omitting rows entirely if they have NAs. This isn't always the best solution, but it is a quick and dirty one. So we're going to use that for this specific session. Yes, omitting NAs is the easiest way to deal with NAs. It can cause us to lose a lot of data, which is a con of this specific solution, as rows with even one NA are removed entirely. Like, let's say I forgot to get the spider size for one row of data. It's taking out that entire row of data. So it's not always the best solution, but like I said, it's quick and dirty. So it can help us when we're just trying to explore our data and make some quick figures with ggplot. So here's how we would do that. And please do this. So just beneath the row where you created, where you loaded in the data with read.csv and assigned the NAs, just omit the NAs with na.omit. My data equals na.omit my data. Overwriting our data. Okay. And of course, in the future, we will look at alternative ways to deal with NAs. All right, let's talk about ggplot, which is probably my favorite package in R. I'll say that. It's probably a bit of a tie between dplyr and ggplot, but they're both extremely useful, versatile packages. ggplot2 works through what is called the grammar of graphics right here, which is a framework which breaks down a data visualization into different components, like data, aesthetics, and geometries, all that stuff. This concept helps our users build customized visualizations step by step. And we're going to take a look at these components. The data component is your data frame, my_data. It's our spider data, or it's our names data, whatever it happens to be. Typically, it's just a CSV file loaded into R and added into your global environment. That's our data. The aesthetics component adds specific data to the plot. Through aesthetics, we tell R what our X and Y variables are. So it's mapping our data. Oh, I want spider size to be on the X, and I want web length to be on the Y. Those are our aesthetics. Geometries is determining what type of plot we're making. Are we making a scatter plot, a histogram, a bar chart, something else? Facets are used when the data should be split between multiple panels. So for example, I want the top to be low temperature days and the bottom to be high temperature days, something like that. So when we're very easily taking our plot and splitting it into multiple facets. Our final one, theme, is used to change visuals like fonts, colors, shapes, outlines, and labels, all sorts of fun stuff. So these are all the different components. And we are going to be working in ggplot right now for the rest of this class. So please remember, if you have ggplot2 installed, load it in with library. Every time you make a new script, load in all the packages you'll need. So load in your library, ggplot2. If this is not working, it may be because you don't have ggplot2 installed. So make sure you install ggplot2. In the bottom right box, under packages, there's an option to install. And if you don't have ggplot2, make sure it's in there. Okay, so hopefully we are all caught up. We have our data in, we have our package. Let's practice. Let's see what we can do. Let's try making our very first ggplot from scratch. First, let's see what a base ggplot looks like without any additional added components. So it's just the base ggplot. Please type this code into R and give it a try. Congratulations, you made a beautiful nothing. As you can see, there's not much going on with our ggplot base. This is because we don't have any of the components, no data, no aesthetics, no geometry, etc. So when we just do a basic ggplot, that's all it does. It just does this gray box. But of course, we're going to take it further than that. Let's add the data component. Okay, so my data is going to be the first argument in our ggplot function. ggplot my_data, which is our spider data that we just loaded in. Okay, so give that a go and see what it does once we give a data component to our ggplot. And of course, we get nothing again. But why? We gave ggplot our data. Well, this is because ggplot has no idea what to do with the data. It knows what data to use, but what does it do with it? Is it looking at spider size or web length or spider family? It has no idea. So this is where we need another component. We need aesthetics. We need to map our variables. So here we add in the second parameter here is AES for aesthetics. And then inside the brackets, we put in all of our aesthetics. So the only thing I'm going to worry about right now is X, our X variable, which is the x-axis, should be equal to spider underscore size. And I'm typing spider size exactly as it appears on the data set. No lowercase s. If I forget the underscore, it's not going to know what it is. So I'm making sure I'm typing the variable name exactly as it appears in the data frame. Okay, so now we have our aesthetics. Give that a run and see what it looks like. Okay, we're slowly getting somewhere. We have the gray box still, but we actually have some stuff going on. We have an x-axis now, and it's based off of spider size. Okay, so now we're ready to actually choose a plot type and get the data plotted. We can do that with the geometry component. And this is where things will really start to get interesting and not be so plain gray boxy. So we have everything we did before. My data is our data. AES, X equals spider size are our aesthetics, mapping X to spider size. And now we have geometry. So we add the geometry type to the end of the ggplot. So plus geom histogram is what I'm doing here. And it could be something else. It could be our geom scatter plot. It could be a pie graph. It could be any sort of thing. But here we're just practicing with a histogram. So we're adding plus geom histogram. And voila, an actual real plot. We now have a histogram. From the base ggplot, we used our data, selected spider size as X, and mapped the data to a histogram geometry. With just those 4 components in total, we can make tons and tons of different figures, which gives us great information about our data. But just for the sake of getting an idea of what the other components do, let's keep going through and look at the rest of them. Okay, facets. Let's add some facets. Remember, facets occur when we divide our figure into panels based on a variable. So we're going to try creating facets based on web type here. We do this with plus, so this is all our original code, just copy and paste it to a next line, plus facet wrap, and then the little tilde to indicate how we want to wrap our facets, web underscore type. Okay. So this is what we're doing. We're creating our panels based on web type. So every different type of web should have its own histogram. And here we go. Pretty cool. We have our orb web type, our sheet tangle web type, and our tangle web type. And all of them have a different histogram for their spider size. So right away, we can see that there are like a whole different situation for each one of these. So it's really easy to just compare right off the bat what's going on with our spider size histograms in these different web types. Awesome. Okay. Our last component is theme, which controls the visual settings of the plot. So just like geometries, all we're doing is adding it onto the end. And of course, this is all just copy pasted from the line before, adding on our theme in purple. And we're just going to use a pre-built theme called Theme Light. Pretty nice, pretty easy. Down the road, we're going to learn how to make our own themes. But for now, let's just try the pre-built theme underscore light. Give that a run, and pretty much the same thing as before, but we see it has a different theme. So the background is white, and there are a few other differences. It's pretty subtle, but we see how using different themes can give us a different general overall appearance and get rid of that ugly gray background. Okay, so since we've practiced a bit already with histograms, let's learn a little bit more about them. A histogram is basically just a graphical representation of the count of a numeric X variable. Okay, that makes sense? So let's back up just to the bare necessities of a histogram. We're going to just keep it to the data, aesthetics, and geometries. You already typed this exact basic thing before we added in facets and themes. So just make sure you copy this to a new line of code, and that's what we're going to be working with. And for some inspiration, here are all sorts of examples of histograms made in R. There are all sorts of interesting things you can do to a ggplot histogram. You can add labels, different bin widths, like all sorts of things, overlapping histograms, density curves. Those are just a few examples of things you can do with histograms in R. We're going to go over some basic options today for how you can customize it. But I encourage you, as you make ggplots in the future, to look online for information on how to do some of these other tricks. One great resource is the ggplot2 cheat sheet, which you can just get online by looking up ggplot2 cheat sheet. And look at this. As you can see, it's a very detailed and helpful guide that you can just reference anytime and go, oh, hey, how do I do this one little thing in ggplot again? Pop open your cheat sheet and, oh, that's how I do it. Excellent. And you can find it online, like I said, by just searching ggplot2 cheat sheet. And there are also cheat sheets for other packages like dplyr, so don't be afraid to consult the internet for our help. It is super great and super easy to do that. One histogram ggplot feature I do want to practice with you guys is bin width. Bin width defines how wide each bar of the histogram is, and it's specified within this geom histogram. So here we have our geometry, right? Like this is just our basic data, aesthetics, and then inside the geom histogram function, we can specify bin width. And please try typing in the code below and see what a bin width of 1 looks like. And when you're done that, I want you to see a bin width of 5 and a bin width of 0.05. I really want you guys to get an idea of why it's important for us to specify bin width and which bin widths can be best for actually visualizing our data. As I always want to manually choose these when I'm creating histograms to make sure that I'm creating the most useful and informative histogram that I can. Okay, and when you're done that, we're going to shift gears a little bit and talk about themes. So remember we used a theme a few slides ago when we were testing out each component. Our pre-built themes change the visuals of your ggplot. And ggplot2 has so many pre-built themes in it, and there are packages that contain even more themes. Once you select your preferred theme, you add it to your ggplot with a plus theme underscore minimal. Here are some examples. These are some themes that are pre-built into ggplot. Personally, I really like theme minimal, theme classic, some of those ones. But take a look and see what kind of sparks your interest, what gets your attention. There are also many packages that exist to provide additional pre-built themes. So just to get these in your repertoire, get them loaded into your R so you can use them anytime you want, please install and load in with library the GG themes package and the GG dark package. So it's also giving you some practice in installing and loading in new packages, because this is something you'll do all the time. And here are some GG themes, as well as themes from the GG dark package. And there are many, many, many more online, which you can use to easily change the look of any ggplot. So please, what I'd like you to do is add a theme that you like to your ggplot, just for practice. Add any of these or the ones on the previous slide. Well, back here. So please choose one of these you like and add it to your ggplot, just to practice and getting an idea of how you can very quickly just make your plot look that much nicer. Okay, let's talk a little bit more about geometries. We know we can use geometry to pick the type of figure we will make. In our case, we chose a histogram. But we can customize what the histogram looks like within the function, like we did with bin width. So here we see we picked bin width equals 50, and there's so much more that we can do. We can change the color of the histogram to red. We can change the fill to purple. We can change the size to 9.5, all sorts of things. So I would like you to please give this a try, put this exact code in. So just copy paste down and then use this code and see what some of these parameters look like when we're messing around with them. This graph will not look pretty. It will look quite offensive, actually, horrendous, some might even say. But I just want to give you guys an idea of what we can do to customize it. Okay, and once you have given this code up your try and seen for your own 2 eyes the most beautiful histogram you've ever experienced, I would like you to please adjust all of those parameters I gave you, and add a theme to the ggplot to make a nice looking plot. So adjust it, kind of work off of what I gave you as a template, and adjust the values until you have something that you like, something that you think is informative, that has a good bin width, and some nice visuals that will just impart the information. I'll give you one example of something that I might do. It's pretty basic, just color. So outline color is black, the fill is light gray, and the size is 0.5. And then I gave it the default bin width. And that's all I really did. It's pretty simple. I might want to increase the bin width a little bit. I might want to give the fill a nicer color like light blue. Just an idea to give you. We all have different aesthetic styles that we like. So this is one example. Okay, let's talk a little bit more about what we can do with the aesthetics component with our histogram. As we've talked a lot about customizing the geom histogram function in our geometries, but what about aesthetics? So we know when we add color in the geometries component, it applies it to the whole histogram. When we change color, it changes the outline color. When we change fill, it changes the fill color. Okay, but what if we want our color to vary according to a variable instead of just being one blanket color? So remember, the aesthetics component controls the mapping of variables. Okay, we use it to tell R that the X variable should be based on spider size. And we can do the same thing with fill. What if we say we want the fill color to be based on spider family? So instead of it just being one color like light gray or light blue or pond scum green, we want it to be based on spider family. So that's what I did in this code. Please give this a try, and you should be seeing a very dramatic change in what your histogram looks like. Okay, with just a little bit of code, like really, this is all the code we did, we get a very informative histogram. What we can see is how spider size varies by spider family. Very cool. We can see there's like a giant tetranaphidy spider up here. We see all the anaphides tend to be kind of in the same range, like all sorts of cool things. We see the Araneidae vary a lot in size. It's very informative, and all we did was add in a new aesthetic. One new aesthetic. We're mapping spider family to fill. Very cool. Okay, let's give you some actual, oh, I got something in my eye. Okay, let's give you some actual practice with this. Here is your first real task of this lesson. I would like you to create a histogram of web length, okay? The fill for the histogram bars should be based on location. Okay, so we're mapping X to web length and we're mapping fill to location. And then in the geometries, I want the bars to be outlined in black. So remember, color is outline color. Bin width should be 2. And I want the theme to be theme_par from the GG themes package. Finally, I would like you to assign the name my plot to your histogram. And then you can call it to see it. Okay, so give yourself a good chunk of time to do this. Try and get it right. And then we're going to take a look at what it should look like after. So take your time with it. And you should get something that looks like this. Okay, so we have web length on the x-axis. Fill is based on location. And we have this histogram. And the other things we see is outline color is black. So each little bar is outlined. And bin width and all of that should be correct too. So this is what you should be getting. If it's formatting really weirdly in your little plot box, you may have to drag it to be bigger one way or bigger the other. Okay, and the other thing we're seeing is my plot has popped up into our global environment because I asked you to name it my plot. So it pops up in your global environment. And anytime you type my_plot, it should display this exact figure. And again, if you ever need help with the exact code, just go into my code in the reference folder, and you should be good to go and be able to look over that. We can also save a ggplot with the function ggsave. Ggsave takes two parameters, the name that you want the file to be, and then the actual plot taken from your global environment, which for us is my_plot. And it will save the file right to your global, not your global environment. It will save it to your working directory, which we usually set at the beginning of each lesson as we're trying to load in our data. So whichever location that your data is saved at will be where this ggsave will go to automatically save your plot. So give it a try, ggsave spiderplot.png. So I want it to be a PNG, and then my plot. So this is what I want it to be called, and this is what I want it to be. Give that a go, and then of course, make sure that the PNG actually saved on your computer. And it should save with the dimensions that you have it in the box. So if your graph is all squished up, it'll save all squished up. So make sure you resize it however you like it before saving the PNG. This same grammar of visualizations we went over, which is like our base, our aesthetics, our geometry, our data, all of that, can be used to make so many different types of plots in R. We use the same grammar as we did with histograms. And next time, we're going to actually try out all of these different figure types and just blast through each one using the same principles that we learned about today. And we're also going to talk about how to choose a plot type, how to know which one will best fit your data. And these are some examples of awesome things that we can make in R: scatter plots, box plots, bar plots, line plots, heat maps, all sorts of stuff. And we'll also learn in the future how to use our grammar of visualization to make them aesthetically appealing and informative, make ourselves some nice looking plots. All right, and with that, I'm going to leave you guys off for this session, and I hope you have a fantastic day. All right, bye.